Okay, today we're gonna work on lab number 6. Okay, lab number 6 is the parallel circuit. Today we're gonna need 4 resistors listed in here. That's all the 4 resistors we're looking for. And if you turn, again, I would like to mention that you have to make sure you read the procedures. Okay, make sure you start from here, read all the thing through, and then you will have an idea on what I'm talking about in this video. Okay, so you cannot like 100% rely on this video. This video can just help you to get familiar with the lab content. Okay? It's not the lab manual, so you still have to read the lab manual. Okay, so if you take a look at the data we're looking for today, we need to fill in table 1. That's like a routine stuff. Get the measure value of all the 4 resistors. And then table 2 is we're gonna measure this thing. And for the last last row, the IT, because we cannot measure current with our multimeter, so you just need to compute it, and that's it. Okay. To compute that, you just use your total voltage divided by your total resistance, or VS divided by RT, and that's it. Okay. And then table 3 is computed. You can do it at home. And table 4 is just a measurement of your total current with R1 open. Okay, total current with R1 open. So this one can be computed as well. I'm gonna talk about it in details. So the circuit you're trying to hook up with is listed in figure, well, actually starting from figure 4. Okay, for each step, if you read through the procedures, for each step you need to add 1 resistors in parallel with the previous circuit, and then eventually you will have a circuit like this. Okay, so what you are supposed to do is, for example, to figure out the table 2, what you are supposed to do is first of all, procedure step number 2. Okay, so you have R1 and R2 connected in parallel. R1 is 3.3K and your R2 is 4.7. Okay, 3.3K, that's 3300. Okay, orange, red. So this is going to be your first resistor. Second one is 4.7K. So it's yellow, violet, red. Okay, 4.7K. Okay, and you need to connect that in parallel, so that's why. Okay, like this. Okay, now these 2 resistors are connected in parallel. So if you go to your table 2, well, R1 is just R1. So R1 in parallel with R2, the measure value of R1 in parallel with R2 is going to be like this. You just measure across it. Because they're in parallel, so you can measure either here or here. It's the same. Okay. So it's 1.91 k ohm, meaning that with these 2 resistors combined, I mean in parallel, the total resistance for these 2 combined in parallel would be 1.91 kilo ohm. Okay, kilo ohm. And then the next column of your table 2, you have R1, R2, and R3 in parallel. So R3 is 6.8 k ohm. So you need to add one more resistors onto it, okay? 6.8 k ohm, it's blue, gray, red. And now you need to put this resistor in parallel with the previous circuit you have. So you need to put the thing in parallel with the circuit you already have, okay? Okay. Like this, okay? Need one more wire. Okay. Now you have R1, R2, and R3 all in parallel. So you need to measure the total resistance in this case. Again, just measure from here. It's 1.49. Okay, so you put that number in the total resistance of R1, R2, and R3 in parallel. And the last one is all the 4 resistors in parallel. So the last one is 10K. Brown, black, orange is 10K, okay? 10K. Okay. And we're using the same way to connect the thing in parallel with the circuit you already have, okay, like this, okay, and then from here to here, okay, okay, now you can see it's all connected together, okay. Now you have 4 resistors connected in parallel, and the total resistance would be, okay, 0.59. So that's like 500 something. You need to switch to a new range, okay, to be more accurate. So it becomes 599, okay, 599. So then you're finished your table 2, okay? So for your table, for the last row of your table 2, you have your IT. So how to compute your IT? IT equals your VS, which is your total voltage, divided by your RT. This is something we already mentioned during the lecture. So the point is, how can we figure out the RT? So from the table 2, you can see your RT is, your measured RT is 599 ohm. That's the one we just measured, right? So you put that, you plug this number in, and your VS is 12 volts. Okay, so your IT measured is gonna be VS divided by RT is 12 volts, or whatever value you have in here, divided by whatever measured value you have in here for your R total. Okay, so this is gonna be your I total measured. Oh, not measured, computed, sorry. Okay, so that's your table 2. And table 3 is the current, okay? Table 3 basically needs to compute the total current. That's the current through each resistor in here. Let's take a look at table 3. So use Ohm's law. I think that's step number 3, okay? Use Ohm's law to compute the branch current in each resistor. Use the source voltage and the measure resistance. Tabulate and compute the currents in table 3. So for table 3, you just need to measure your I1, compute your I1, I2, I3, and I3 and I4. And you already have the equations in here. So I1 is Vs, which is 12 volts, divided by your R1. Your R1 is 3.3 k ohm. Okay. I'm using the 3.3 k ohm in here because I didn't measure the actual value of your R1. So you use your measure value in here, okay? And then you compute I1. And I2 is Vs divided by R2. V3 is Vs divided by R3, etc. Okay? Okay, so you compute all of them. And for table 4, it's like if you removed R1, what the current would be. Table 4, okay. So if you removed R1, means R1 is gone. Okay, it means that you remove this. They have an open circuit in here. So what's gonna be your total current? Total current is, so actually if you remove your R1, if this one is gone, it's like R2, R3, and R4 all connected in parallel, right? So previously the circuit is like this. Everything is connected in parallel and it goes to, and it's also connected to your power supply like this. Okay. Again, this is the figure on, I think it's figure 6, right? Figure 6, yeah, figure 6. Everything is connected to your power supply. Okay, like this. Right now, this one is gone. So if this one is gone, you just take it out because it is an open circuit, right? So you just take it out. And then right now it's like you have R2, R3, and R4 connected in parallel with your R total. So in that case, your I total with R1 gone. Okay, I'll put it like this way. Okay, would be Vs divided by R2 in parallel with R3 in parallel with R4. Okay, so this is the way you compute table 4. As for how to compute R2, R3, and R4, in this case, you can measure them. Okay, how to measure them? You already have the circuit in here. Right now, you just need to measure like the resistance with these 3 resistors combined. Because like I said, if you're trying to measure any resistance, you need to make sure the resistors you're trying to measure is isolated from the rest of the circuits. You cannot leave the circuits like this. You cannot leave them, make them connect to the power supply. You need to disconnect it from here, okay? Disconnect it from here. Now, you only have, 1 to 3 resistors connected in parallel. And then I'm gonna measure from here and here. So you can see the total is 734, okay, 734. Okay, so then you just use 12 divided by this number, then you can get your I total for your table 4, okay? So it's actually pretty simple. Okay, so that's for lab 5, okay? Again, like I said, you need to make sure you read your lab manual first, and then you can turn to this video tutorial to help you on while you're working on this lab. Okay, thank you.